All right, let's talk about a word you hear everywhere these days, blockchain. You know, it's been called the trust machine, and honestly, it might just change, well, everything. It can sound super complex, but I promise by the end of this, it's all gonna click, so let's dive right in. Okay, first, let me just ask you a question. Imagine you and your friends had a shared notebook, but this notebook was kind of magical. It had a rule that no one, and I mean no one, could ever cheat. You couldn't rip out a page, you couldn't secretly scribble over what someone else wrote, and here's the kicker. Everyone's copy was always instantly up to date. Well, that magical notebook, that's pretty much the simplest way to get your head around a blockchain. At its core, it's a shared digital notebook, or a ledger if you want to get technical. The key is that it doesn't live in just one place. It's not on a single company's server. Instead, it's copied and spread out across thousands of different computers. So it's not one book, it's thousands of identical, perfectly synced copies. So let's really get into that. Let's talk about this shared digital notebook because, it doesn't work like the notebooks are used to. It has a few really simple but incredibly powerful ground rules that make it all work. This entire idea hangs on two golden rules. Rule number one, everybody in the network has their own identical, up-to-the-minute copy of the notebook. There's no master version that one person controls. And rule number two, and this one is absolutely crucial, you can only add new pages. You can't go back and change things. You can't delete what's already there. It is a one-way street. Right, so this add-only feature has a fancy name, immutability. It just means that once some information, a transaction, whatever, is written down on a page in this notebook, it is set in stone. It's permanent. It cannot be messed with. And that one simple idea is the bedrock of why we can trust it. Okay, so that leads to the next logical question, right? If you can only add pages, how exactly does a new page get added and approved? Well, that brings us to the rules of the chain. So the process basically works like this. First, somebody wants to add a new entry. Let's say you want to send a friend a digital coin. That proposal gets broadcast out to everybody on the network. Then all the computers on the network work together to check it out. Do you actually have the coin to send? Is everything legit? And if the network agrees that, yep, it's valid, your transaction gets bundled up with a bunch of others into a brand new page, which in the blockchain world is called a block. And this whole process of everybody agreeing, that's another key concept called consensus. It's the magic that lets this system work without a central boss. Instead of needing a bank or some administrator to say, yep, this is okay, the entire network of users comes to an agreement on what the truth is. It's trust created through math and cooperation, not by some middleman. Now here's where the chain part of blockchain really comes into play. Each new block, each new page, isn't just tacked onto the end. It's actually linked to the one right before it, using some really clever math called a cryptographic hash. The best way to think about it is like a unique digital fingerprint, or maybe like an old-school wax seal on a letter. And this is the genius part. Because if you try to go back and change something on an old page, even just one tiny little detail, that block's digital wax seal breaks. But since every seal is connected to the next one, breaking one seal causes a chain reaction, breaking every single seal that comes after it. The whole network would see this broken chain immediately and just reject the fraudulent version. It makes cheating practically impossible. So as you can probably tell, this whole structure makes a blockchain really, really different from the kinds of databases we use every day. So in this next section, let's compare the private diary of a traditional database to the shared public notebook of a blockchain. The biggest, most fundamental difference is this: decentralized versus centralized. A normal database is controlled by one company, one bank, one government. It's all in one place. If their server goes down or if it gets hacked, the whole system is at risk. That's a single point of failure. But a blockchain? It's a network of equals. There is no center. So there is no single point of failure. Yeah, this table just lays it out perfectly. Look at the architecture. Decentralized versus centralized. How data gets modified. Blockchain is immutable, you can only add. A traditional database is mutable, you can change or delete anything. How is stuff verified? On a blockchain, it's through that cryptographic consensus we talked about. In a regular database, you just have to trust the administrator. And finally, transparency. It's super high because it's a shared book versus being really low in a closed-off private system. Okay, so that's all the theory. It sounds cool, but what does this actually mean for us? Why should we care? Let's move on and look at blockchain out there in the real world and shift from the how it works to the why it matters. Okay, let's start with a very real problem. Back in 2018, there was a big E. coli outbreak linked to romaine lettuce. Now, for a giant company like Walmart, trying to figure out where a specific bag of lettuce came from was a total nightmare. It meant digging through paper records, phone calls, siloed spreadsheets. On average, it took them 7 days to trace it back to the farm. In a public health crisis, a week is an eternity.
So Walmart worked with IBM and built a food tracking system on a blockchain. Now every single step, from the farm to the truck to the warehouse to the store, was logged on that shared, unchangeable notebook. So after they did this, how long do you think that same traceback took? 2.2 seconds, from 7 days to less than the time it takes to snap your fingers. That is a game changer.
And that right there is why way back in 2015, The Economist magazine called this technology the trust machine, because that's what it does. Its whole purpose is to create a single, shared source of truth that everyone can see and rely on, without having to trust each other or some powerful middleman. It literally manufactures trust using technology. And this trust machine isn't just for tracking produce. I mean, the potential is just massive. Think about a voting system where every vote is a secure, tamper-proof record that anyone can verify, or sending money across the globe in minutes instead of days without paying huge fees to banks. It could even power a digital ID that you control so you can prove you're over 21 without showing your address or exact birth date. And then you have things like smart contracts, which are basically just agreements that run themselves automatically once the terms are met. It's like a vending machine for complex deals. Now look, blockchain isn't a silver bullet for everything. It's still new and it has some very real challenges to overcome. So for our last section, let's take a quick look at what's next on the horizon. One of the biggest hurdles is something the experts call the scalability trilemma. It's this super tricky balancing act between three things you really want: ironclad security, true decentralization, and lightning-fast speed. The problem is, it's really hard to have all three at once. Early blockchains, for example, often had to sacrifice speed to make sure they were super secure and decentralized. But there's a really exciting solution taking shape, and it's called a layer 2. The easiest way to think about it is like building an express lane on top of the main highway. These systems can bundle up tons of transactions, process them really fast off-chain, and then they just post the final summary back to the super secure main blockchain. This is how the tech plans to go from handling a handful of transactions per second to handling millions. And that really brings us to the final thought here. At its heart, blockchain is a brand new tool for building trust. The Walmart example shows how it can solve huge problems with verification and tracking. So the big question it leaves us with is this: if we can now design systems where trust is just built in, where we don't need those slow, expensive, or sometimes untrustworthy middlemen, what other huge, seemingly impossible problems are we finally going to be able to solve?